The heart of the galaxy is spewing bursts of gamma rays, activity which has been attributed in the past to the signals of dark matter. Now, two new studies from the US and the Netherlands refute this theory, suggesting instead the signals are evidence of other astrophysical phenomena, including fast-rotating stars called millisecond pulsars. These research teams independently determined that such signals are uncharacteristic of those expected from dark matter. Separate teams, one based at Princeton University and the Massachusetts Institute of Technology, and the other based in the Netherlands, investigated this dense and complicated region of space to trace the origin of these signals. Earlier studies have suggested that these gamma rays from the inner Milky Way are the result of collisions between invisible dark matter particles. The research from Princeton now finds that this may not be the case. Our analysis suggests that what we are seeing is evidence for a new astrophysical source of gamma rays at the center of the galaxy, said Mariangela Lasanti, an assistant professor of physics at Princeton. This is a very complicated region of the sky, and there are other astrophysical signals that could be confused with dark matter signals. The center of the Milky Way holds a dense concentration of mass, including clusters of stars and a black hole, and confirming dark matter collisions in this region would further our understanding of the universe. Finding direct evidence for these collisions would be interesting because it would help us understand the relationship between dark matter and ordinary matter, said Benjamin Safdie, a postdoctoral researcher at MIT. The Princeton/MIT team used image processing techniques to examining what the gamma rays from a hypothesized dark matter particle collision should look like. These are known as weakly interacting massive particles, WIMPs. The team also studied images of gamma rays from NASA's Fermi Gamma Ray Space Telescope. Gamma rays are the highest energy form of light, and according to a widely accepted model of dark matter, they should appear in a smooth distribution in the Fermi images. Other astrophysical phenomena, like pulsars, would appear as isolated, bright pixels. After studying the images from the Fermi telescope, the researchers found that the photons, high-energy particles of light, were clumpy, not smooth. This indicates that they most likely were not caused by dark matter collisions. The researchers suggest these clumps may be evidence of millisecond pulsars. To further explore this, Lasanti says researchers could use telescopes that detect radio frequencies. While the two studies haven't precisely determined the source of the gamma rays, they independently conclude that the case for dark matter particle collisions is an unlikely one. As research progresses, the universe may one day reveal the answer. Either we find hundreds or thousands of millisecond pulsars in the upcoming decade, shedding light on the history of the Milky Way, or we find nothing, said Christophe Weniger of the University of Amsterdam, and lead author of the Netherlands study. In the latter case, a dark matter explanation for the gamma ray excess will become much more obvious. Dark matter has long remained elusive, though it is thought that these particles make up roughly 85% of mass Indiana the universe.